So in this video, I'm going to talk about bond formation in organic chemistry. So there are two types of bonds, ionic and covalent. And so an ionic bond is something that occurs between oppositely charged ions. So occurs between oppositely charged ions. So for example, sodium can give one of its electrons to chlorine, and so that would make sodium positive and chlorine negative, and then so they're attracted to each other. Remember, positive is attracted to negative, and so cation would be the positive charge, the positively charged ion, and anion would be the negatively charged. So chlorine is the anion in this example, and the cation is sodium in this example. And remember, key thing here to remember is they're attracted by electrostatic forces. Covalent bonds, on the other hand, occur between two neutral atoms. So two neutral atoms, and it's essentially the sharing of electrons. So in ionic, one electron is given away, and so that makes a molecule negative, atom negative and another one positive, and so that attracts. In a covalent bond, electrons are shared. So electrons are shared in this bond. So for example, if you have carbon with 4 valence electrons and hydrogen with 1 valence electron, let's say you have 4 of these. And so what will happen is carbon will share with 4 different hydrogens. So like that. You know what? Let's use red for carbon. We'll use carbons and the carbon electrons in red. So here, those are the electrons that came from carbon, and the ones in black came from hydrogen. And so that is a bond. That's the same thing. This molecule right here is the same thing as this. Just the electrons are drawn out. And remember, each one of these lines represents 2 electrons. And so there is essentially a goal of every atom. So every atom essentially wants to achieve a closed shell known as an octet. So it wants 8 valence electrons. The one exception is hydrogen. We'll put over here. And hydrogen is happy with 2 valence electrons. And so the octet rule, it essentially means it's isoelectric with a noble or rare gas. So it has the same number of electrons. If the octet is achieved, it's the same number of electrons, E minus electrons, as a noble gas. And noble gases are very non-reactive. One thing I forgot to mention, the hydrogen rule up here, that is called the duet rule. So hydrogen can only accommodate 2 electrons. And so more on covalent bonds. So covalent bonds, there are 2 types of covalent bonds. there's polar and nonpolar. And so what polar and nonpolar means is that it essentially means how well electrons are shared. So certain atoms pull electrons more towards them than other ones. And so that would be defined as a polar bond. And certain atoms, for example, if you have two of the same things, for example, O2, oxygen, that would be a nonpolar bond. So polar, so electronegativity, and remember electronegativity is the amount of affinity, so how much an atom will pull electrons towards it. So electronegativity differs by a significant amount. Some people define the amount differently. And nonpolar, no significant electronegativity difference. For now we'll define it as that, but it's actually if the way the molecule is arranged can affect what if it's polar or not. And so back to the octet rule. The octet rule, there are some exceptions. And so let's talk about that. So we have the hydrogen exception, which is known as the duet, to be isoelectric. So oxygen only needs 2 electrons to be isoelectric with helium, for example. Group 3, so boron and aluminum, that group, are stable with 6 outer / valence electrons. So for example, a molecule could look like this: chlorine, and then that would be stable, but it could also look like this. It could have 4 bromines coming off of it, and then this would give it a positive charge. And then you could have, for example, it bonded to, whoops, sorry, drew this wrong. So bonded to an oxygen, H, this would actually be a negative charge. This would be a positive charge. And so this could be another molecule. Boron can still have an octet. And then so atoms in period 3, remember periods are the rows and groups are the columns. So period 3 plus, so anything above 3, can exceed the octet. So for example, the most common one would probably be sulfur. You could have something like this. In which the sulfur has 6 different bonds, and so it can have up to 12 electrons